Hello, class. This is Mr. Block. I'm gone today, obviously, so I'm recording this PowerPoint so you guys can watch this while I'm gone tomorrow. So we're going to talk about the five senses today. We just covered the nervous system, and so this is part of the nervous system, but we make it its own chapter because there's a lot of information here. So we all know our five senses: sight, hearing, smell, taste, touch. Realize that you do have other senses other than those. You have sense of heat. You have something called proprioception, where you can detect where your body is even when your eyes are closed. So we always talk about your five senses, but in reality, you have more than that. And these are just all different types of specialized receptors that take in stimuli. All right, 70% of all the information that you take into your brain from the outside world is visual. Okay, so we have binocular vision, which we're able to see objects from two different vantage points, and by doing that, our brains can use that information and give us depth perception. If somebody loses an eye, they're probably not going to be a baseball player or a basketball player because you lose that ability to see depth perception. I mean, we can still kind of get some depth perception by moving our head left and right, but it's a lot harder to do. Okay. Around the eye, we have our eyelids and eyebrows and eyelashes, and that's just to keep particles from entering the eye. Okay, so here's a look at the eye and some of the different structures. You're probably familiar with most of these. We will have a quiz over the different parts of the eye and the ear as well. So we can start on the outside of the eye and talk about the cornea, which covers basically the opening to the eye and the front of the eye. This is tough, clear material, and this is if you've ever heard of somebody getting a scratched cornea, that's what they're talking about. Inside of there, we have actually two different chambers in the eye. We have the anterior and posterior chamber. Okay, the anterior chamber is filled with something called aqueous humor, and then the posterior chamber is filled with vitreous humor. So this is what gives the eye shape, and basically it's a clear jelly-like substance. But sometimes as you get older, there gets imperfections in there, or you can actually get even a tearing inside of that. And if you've ever seen an eye floater or something that in your field of vision, it's usually something in the vitreous humor. Okay. The opening to the eye that allows light into the eye is the pupil, and the size of that is controlled by the iris, which is the colored part of your eye. Behind that is the lens, and the lens is what's going to refract and bend the light and focus it. So it is trying to focus it onto the back of the eye, which is called the retina, which has light sensitive cells in it. So it's able to change shape by the ciliary bodies. Now, as you get older, the flexibility of that lens changes, and that's why usually people have to start wearing reading glasses. All right, the white part of the eye that surrounds the rest of the eye is called the sclera. And at the very back, you have the optic nerve, which is where all this visual information is going to enter the brain. Okay, so I basically talked about most of these different structures: pupil, lens, iris, and retina. And so this is a look at the retina and the different types of photorecepting cells that you have. So you have rods and cones. Okay, rods are what gives you your night vision, your blacks and grays. Okay, and then cones give you your color vision. Okay, so certain people may have there's several different types of cones, and a person can be missing one of those cones. Imagine each cone is one of the primary colors, and if you're missing one of those, you may be colorblind in one of those color areas. Or if you're missing all of them, you would just see black and white. But basically, the light information is collected on the back, and then this is turned into an electrical signal by the photoreceptors and then sent to the brain through the optic nerve. All right. So sometimes when we're born, sometimes as we age, the shape of our eye changes. Okay. And when that happens, that changes the refraction, the point of refraction. Okay. And when this can either be too close or too far away. Okay. You can see there, if you have an astigmatism, there A is focusing too close. All right. And then A is where it should be. So this astigmatism is when we have a distortion because the light rays are not coming to a single point. And this can happen 2 different ways. We can be farsighted or nearsighted, hyperopia or myopic. All right, and so this is kind of backwards. I always had trouble with this when I was a kid. I'm nearsighted, but I don't see things far away very well. It's talking about the focal point. So if you are farsighted, the focal point is too far away, okay? Versus if you are nearsighted, it is too near, okay? So you can see that in the diagram down below here. So how do we fix that? We use corrective lenses that changes the index of refraction and helps the eye, focus the light in the correct point. Another interesting thing about your vision, you actually see everything upside down because of the way that when that light is bent, it actually flips the image upside down, and you can imagine an upside down picture on the back of the eye where the retina is. But your brain just naturally flips that around for you. Okay, we've already done a test where we've done the Snellen test, and so that is how you determine your far and near vision. 20/20 is considered perfect. You can have better than 20/20 vision. And some of the different eye disorders that are out there, the first one is cataracts. So basically this is a cloudiness in the lens of the eye. So they can either remove that cloudiness or, nowadays they can put a pseudo lens in there, remove the lens. And basically the lens is kind of like a jelly-filled donut. It's got a different, in the middle of it, it's kind of a different structure to it. Okay, and they can actually suck that out and put new stuff in. Glaucoma is where you have basically high blood pressure in the eye, and if this isn't treated, you can actually lose your vision. So when you go to the eye doctor and they give you that puff of air in your eye, that's what they're checking for is glaucoma, and see how the eye reacts to that. Okay. Blindness is obviously another disorder, and there's various ways that can happen, whether it's a congenital defect, macular degeneration, or some sort of trauma to the eye. And if your vision is 2400 with all the correction they can put in it, that's when you're considered legally blind. Okay. All right. Your ear is obviously another one of your structures. It does hearing and your equilibrium. Okay, most of us understand the hearing part, but we'll talk about your equilibrium or your sense of balance as well. So you have an external, middle, and inner ear. So the external part, or the pinna, is basically designed to focus sound waves into the ear. So it is going to focus it into your external auditory meatus. That is the hole in your skull. Okay, you have glands that make earwax, and that helps keep out bacteria in the ear. So between the external and middle ear, you have something called the tympanic membrane, which is kind of like the head of a drum that sound waves vibrate this. And then when that tympanic membrane vibrates, it is going to vibrate those 3 small bones that we talked about before, the malleus, incus, and the stapes. Remember the malleus, it kind of looks like a mallet. the incus kind of looks like an anvil and the stapes looks like a stirrup, or back in the day, that's what they thought it was. So these three bones move, one moves the other, and so on and so forth. And then it will go into the inner ear where the cochlea is. You also have a something called the eustachian tube, which basically is a tube between the ear and your pharynx, your nasal pharynx. And this is what allows you to equalize pressure. If you've ever gone to the mountains, you've had that feeling, that sensation of your ears popping or getting pressure behind the ears. And that's because the air pressure outside of the ear is less. And so if the air is trapped inside of the ear, it's going to push on that tympanic membrane. And you have to equalize that pressure. And the eustachian tube is what allows you to do that. Here's the structure of the ear. You can see the pinna or the auricle. You can see the external auditory meatus and the tympanic membrane. And there's the malleus, incus, and stapes. And then that is up against another structure called the cochlea. Okay, and we'll talk more about that. Okay, just another look at some of the different parts of the ear. All right, so the cochlea is a snail-shaped structure in the inner ear, and basically it's got these hair-like structures, and you can imagine some of the hairs being thicker and some of the hairs being thinner, and each size of hair is vibrated by a different frequency of sound waves or vibrations. Okay, so this is located in the organ of Corti, and there's a liquid in there. And so as those sound waves move the hairs, the stimulation of those hairs turns that into an electrical signal, and that is sent to the brain and interpreted as sound. So as you get older, or if you listen to a lot of rock music or things or maybe shooting a gun, if you don't protect your ears, some of the finer hairs will be damaged. And if those hairs are damaged, you're going to lose that frequency of hearing. So basically that's what they are doing when they are giving you a hearing test, is they're trying to see if there's any damage there. Okay, basically, talks about your hearing, and talks about what can we hear. We can hear between 40 and 140 decibels. That our ears, we're definitely not the best in the animal kingdom. There's obviously dogs and other animals that can hear different frequencies than we can hear. So we're pretty limited. Okay, your ears also control your balance. You have 3 tubes in your ear that have liquid in them. And when you move your head left and right, forward and back, and so on and so forth, each of those is aligned in a different plane. Okay, and you can imagine it's like a balance with a little bubble in it. And as that bubble moves back and forth, your brain interprets where you are in space. So that is what allows for you to have your sense of balance. Okay, now let's say you do get on a roller coaster, or you do the activity where you put your head on the bat and you spin around really fast. Well, what happens to that liquid in your ear? It's going to all 3 tubes. It's going to get pulled to the outside because of gravity, centrifugal force, and your body doesn't know how to interpret that, and so that it can't align itself, and so basically you're off balance and you fall down usually. Okay, we're not going to talk a lot about your skin. We talked more about it during the nervous system, but realizing your skin, you have different types of receptors, from touch to pressure to pain to temperature to injury, and those are going to be spread out on your skin. Remember, we did that 2-point detection where we touch 2 different spots on your finger versus the back of your neck versus your arm, and in different areas you have more or less of these different types of receptors. Okay, so some of them are deep, some of them are close to the surface, some can even, like just touching the hairs on the back of your arm, you can feel that. Okay, sense of smell Okay, inside of your nose, when we looked at the brain, we saw those olfactory receptors that are right there in the cribriform plate inside of the skull. And so that is what gives you your sense of smell. And basically, it detects different chemicals. Okay, so there's about 80 different chemicals that your brain can interpret. And basically, it's like a lock and a key. If the chemical has the right shape to it, it'll lock and stimulate um, that type of receptor. Okay, let's say you're in a place where that you're constantly, you smell, so you go come in a room and it just smells really really bad, and then 5 minutes later it doesn't seem so bad. Well, it's just because all the receptors are full, and it's kind of noise at this point. It doesn't really detect it anymore. Okay, so your sense of taste is obviously on your tongue. You have different types of receptors: sweet, salty, bitter, and sour. And they've always shown in the past, like the tip of your tongue is more salty and more sweet on the sides and bitter in the back. And that's really not quite true. There's a little bit where there's more in certain areas, but you can kind of detect all of that everywhere. And um, your sense of flavor, okay? Your sense of flavor is kind of a combination of your sense of smell and your sense of taste, okay? Because, obviously, if you can't smell your food, it tastes really bland. If there's a food that you don't like and you plug your nose, you can't taste it very well, and so you can eat that bad food that your parents want you to eat. Okay, so that's what gives flavor. It's a combination of your sense of smell and your sense of taste together. And if you think about that, 4 different types of taste buds plus 80, that gives you all kinds of different combinations that you can have. Okay, and basically that's what I just talked about there. All right, and that's it. That's our 5 senses.